We have learned in previous lecture the cross validation technique. Why actually we need the cross validations in KNN, that is to find the proper hyperparameter. So in KNN we see, in KNN K is actually a hyperparameter and to find the right K we need the cross validation technique. And we will see, we have seen this thing in previous lectures. Now there also have a limitations. To avoid this, to overcome these limitations, we use here the k-fold cross validations. So instead of talking the k, actually here we are calling KNN. The k is also a hyperparameter, so I'm calling here the k dashed cross validation. There I think it will be clear. So it will be, instead of k, I am calling k dashed cross validation technique. Is actually k dashed cross validation. Both are the same thing. So instead of using k, I am calling here k dash. So let's see what is actually the problem of this cross validation. So the problem is that we know, the more training data set, if we use the more data in our to train a model, so the model will be better so much. So the thing is that we know, so more the training data, that implies the better our algorithm. Is we already know this thing, that more data we use, our algorithm will be better so much. But you will see in the cross validations of what we are doing. We are doing in cross validations, we have a data set that called dn, and we partitions the data sets randomly in three parts. We randomly partitions the data sets in three parts. So the one part is called the training data, dtrain. Another part is called the d cross validation data, and last one is called the d test data. And typically we have seen this data is divided in 60% for training data, and 20% for cross validation data, and 20% for test data. We have seen this thing in typically, but these things depends on situation to situations. And we have using these two set of data, that is training data and cross validation data, to build our k nearest neighbor model, to build our KNN model. And how we'll build this? We are simply determine our k from this cross validation data. We have simply determined this k from our cross validation data, and we are taking this nearest neighbor points from the training data. We have seen this thing in previous lectures, and according to that, we build our classifier. For example, our algorithm that called if we will build according to this thing. Now here this data sets, this d test data sets are called the unseen data set. This thing actually unseen data set, or this data we are using to simple finds the accuracy of our model if. We have seen this thing in previous lecture. Now let's see what is the main problem now. Now let's see about the problem. What is actual problem? So the problem is only here to build the our model only for we are using only 60% data to take our nearest neighbor points. Only basis of this 60% data we are taking the nearest neighbor points, And on this, because of this only, it is a small number, and we know the more training data for our better algorithms, but from the whole data we are taking only 60% data to train our model. So we are only consider here only 60% of the data, only 60% of data we are using to take our nearest neighbor points. Okay, and 20% of the data we are using for cross validations, because of to determine our best k, what will be our k value. Only 20% data. So total 80% data we are using, 80% data using to compute. So of overall data we are simply using 80% of data to compute the NN. Means nearest neighbor point. So instead of actually from whole the data, just you have see only 60% data we have considered to treat as a NNN, and to calculate the best k we are using the 20% data. So for this ANN we are losing the informations for 40% data. You have seen only we have considered the 60% data to take the NNN, to take the nearest neighbor points, and for only rest of the 40% of data, it means 40% informations of the whole data we have totally lose here. So this is the problem. And here rest of the 20% data is taking as the test data, and this data is called the, actually this data is called the unseen data. We have seen this thing. So this is the main problem here. This thing only we are using the 60% of data. So here 40% informations we lose here. Instead of, if we somehow now our motto is somehow we have used this 80% of this data. So in this case, in the sample cross validations, we see that we are using only 60% of data. Only from the whole data we are using 60% of data to take the nearest neighbor point, and we have losing the 40%. So if we some doing some hack to improve this model, that somehow we are interested to find 80% of the data to compute the NN. So we have doing some him somehow somehow we to consider to take 80% of the data as NN nearest neighbor points. Here we are using only 60% data, but doing some techniques, doing some hack, doing some engineering of this on these algorithms, we are interested to take the 80% of data as our NNN, means nearest neighbor. Okay, so let's see how we will do that. So the first thing we have to do here, so first thing we are here, actually we are here, suppose this is our training data. Suppose let's take, just so first what we are doing, first stepwise. I think it will be better. Let's write down these things stepwise. How we'll do that? So first we have our whole data. We are doing the partition randomly. So this partition is called the train data, and this partitions is called the detest data. And we have doing these train partitions of the 80% of the data from the whole data sets, and we are taking the 20% data from the whole data set as detest data. And on this 80% of data, on this 80% of the data, we will build our f or knn. And simple, on this 80% of data we used as nn, and also on this 80% data we will use to find our best k. Both the 80% data we have used to take as our nearest point, nearest neighbors, and also this 80% also data we have used to find the k. How we will do that? Actually, in previous situations, in cross validations, we have seen only 60% data we have taken as nn, and only 20% data we have taken as to find the best k. But here we have using the 80%, the whole 80% data to take as our nearest neighbor points, and on the whole 80% data of our training, so we have take to find our best k. So let's see how we will do this job. In this the first step, we are divide partitions our data sets as detrain and detest as 80% for detraining data and 20% for detest data. So let's see what is the second step. So in second step, we are taking our detrain data. We are taking our detrain data here. This is our whole detrain data, and we have partitions d data in 4 partitions. We have partitions d data in 4 partitions. This is the whole d train data. We have partitions in 4 parts. So this is sample first chunk d1, this is second chunk, this is third chunk, and this is fourth chunk. We have just partitioned this data in 4 partitions. First one, second one, third one, fourth one. Okay, and we are doing this job randomly. We have doing this job randomly. Okay, and this job is doing only, just consider let we have partitioned this data in 4 equal size, 4 equal sized parts. Let we may do this thing 5, we may do this thing for 6 equal size part, we may do this thing for 10 equal size part. So let's take, for simplifications, for easy of our calculation, let's take, we are doing the partitions in 4 equal chunk randomly. Doing this job, we are doing this job randomly such that in a way that d1, d2, d3, and d4, each partitions of them are equal sized. Okay, if these 4 partitions are equal sized, and total d train are occupy the 80% of the whole data, 80% of the whole data d train is occupied. So each parts of the small size, each parts of the small chunk of the d train occupy the 20% of the east of the whole data. So each of them will take 20% of the whole data. I think this concept is clear. I will divide it then, and how this thing is doing. This is the second step. Okay. So I think up to this step you are clear all about. Now let's see what we're doing in third step. In third step we have doing, so it will be better if we draw a table first. visualizations through table, it will always better. So let's take it's our table. It's okay. It's our table. Now we are dividing this table through four columns. We are divided these tables through 4 columns. This is column 1. This is column 2. This is column 3 and 4. Okay. So in the first column we are taking the k value, and second column we are taking what is our actually training data we have considered to train our model. In third column we are taking the cross validations and which data sets we have used to take as a cross validations. Same table for cross validations, we are doing the same table. Okay, so let's see. So and then last consider on the accuracy of the data on our cross validation data sets. We find the accuracy. So let's see. So suppose we are starting this to calculate this table. Suppose we are first taking k is equals to 1. So k is equals to 1. Here actually how many parts we have doing these t-train partitions? How many parts? In 4 parts. So we are simple, instead of using d-train and cross validation 60-20, but just doing the same job on these 4 partitions. First we have taken this to train our model. In the whole training data we have taken the first 3 chunks as our training set, that is d1, d2, d3. I think you have understand what is actually mean about chunk. Chunk means these small portions of the d train. This is your one second chunk, this is third chunk, this is the fourth chunk. Okay, so we have first I'm considering these 3 chunks for training data, and I'm considering the d4 for cross validations. I'm just distributed our detrain data like that to train our model. Okay, suppose let's take for this partitions and for the on these cross validations of d4, or we get an accuracy. Suppose let's take its accuracy, it's we get a4. Because of a4 we have taken, because we are considering our cross validation data d4, so let's take our accuracy of this thing is a4. Now for the same k is equals to 1, now we are changing the data sets. Here we are using the d4 as cross validation data. Now let's take, we are considering the d3 as our cross validation data. So what will be our training data? d1, d2 and d4 will be our cross validation data. Suppose let's take, in such situations our accuracy of this model is a3 because of this d3. And now next step, the same thing repeating. And suppose let's take for the same thing we are repeating for k is equals to 1 for the cross validation data sets d2. So what now will be our training data? d1, d3, d4. So let's take here accuracy is da2. The same thing for k is equals to 1. So now we have taken our data cross validation d1. So it will be d2, d3, d4. So let's take its accuracy is a1. Okay, I think you have understand these calculations of the table. I think you have understand this. So we have considered all the points. Just a minute, I this color. Okay, I think you will understand this, how we'll compute this table. Just I'm taken the one chunk for cross validations, and I'm repeating this thing until we have taken until we will take our until we will complete or the S chunk the cross validation data, the same thing, and the rest of the data we've taken as training data, and it's finding where then we find its accuracy. So we will see when we've taken the cross validations, when we have taken the cross validation model, then we have finding the best scale like that. We have sample draw one image. This is our actually k value, and this is sample our accuracy on the accuracy. This thing is accuracy on the cross validation data set, and we will get this curve like that. If k is equals to 1, k is equals to 2, k is equals to 3, up to k is equals to n. And suppose let's take the maximum value of the accuracy is 1 and minimum is 0 here. So we'll got this value like that. Like that, we will got this value. Suppose let's say over here our maximum value for this curve is here. Actually, here it will be I have a okay like no problem. We have simple omit this thing, and I am drawing our one value is here. Suppose let's take here I am getting the maximum value of this curve. Suppose let's take I have got this value for k is equals to 3, maximum value for k is equals to 3, we have got the maximum value. Okay, so if you just see, for to plot this data we actually need a single value for a single k. Suppose here we have taken k is equals to 1, and just same thing also, just complete the table first, then I repeat this how we'll get this. So then the same thing also doing for k is equals to 2, k is equals to 2, k is equals to 2, k is equals to 2. So how many times this thing repeating, how many times, because we have taken here actually k dash, actually here k dash is equals to 4, because we are dividing our training data sets in k fold, k dashed fold. Suppose so, because of this name we have taken here k dashed fold cross validation, k dash fold cross validation technique, because we are dividing our training data set in k dashed folds. Here k dashed sample in this example 4. What this is here k dashed, this is here k dashed here is equals to 4, and sample it is k dashed is equals to 4, k is equals to 2. The same job will be repeating until we have reached here, until we have reached here k is equals to n. Okay, so same thing, same jobs we have to do. So for first we have in calculated cross version d4, then d3, then d2, then as well d1. So this thing will be d1, d2, d3. This thing will be d1, d2, d4. This thing will be d1, d3, d4, d2, d3, d4. And suppose let's take this value is a4, so let's take it is a dash 4, a dash 3, a dash 2, a dash 1. Let's take, so actually we have just we are doing the same things for n data sets. For n if we have n number of data point in our training data, if we have n number of data points in our training data, we have doing the same things for n number of data sets. So let's take, so here d n is equals to n1. So we are doing this job for n1 times. We have doing the pictures for n1 times also. So we have seen we have needed a one value for h k is equals to 1, for k is equals to 2. So how to find this? How to find this job? So to find this single value, we are simple taking the average of these four values, so simple we are taking average of these four values, a1, a2, a3 and a4. We are taking this average. So let's take, for here we are considering k is equals to 1, so let's take our average value is equals to a of k is equals to 1. So simple here the same thing, the same average value for k is equals to 2 is, let's take here average value is equals to a k is equals to 2. The same thing here, the let's take here average value is equals to avj of k is equals to n1. So now we are finding, we are plotting this thing. Suppose here this for k is equals, for k is equals to 1, this value will be a k is equals to 1. For k is equals to 2, this value will be k is equals to 2. And for k is equals to n1, this value will be here, somewhere here, so curve will be here, so this value will be k is equals to n1. I think you have understand. Suppose let's take all these n1 values, among all these n1 values, suppose let's take we got the highest value here in the at that point, and where k value is equals to 3, where k is equals to 3, we got the maximum value. This means what? This means we got an accuracy. This means we got an accuracy on knn for k is equals to for k is equals to 1. This means actually we have actually n number of data sets, n1 number of data sets, so we have got accuracy on knn for k is equals to 3. And which, suppose let's take its accuracy value with accuracy k is equals to 3. Okay, I think now we have choose how we have utilized these 80% of data. Suppose we accuracy on with accuracy this. I think it sentence, if you just omit this line, then sentence will be okay. So for knn for k is equals to 3 with accuracy k is equals to 3 if this one is maximum. Just we have taken this picture. So what we are getting here actually, just to summarize this, we are simple find this if for fknn, just we have just if we just summarize this thing, we have a build our if, so 3nn by simple following this thing. So by using the nn, this we have taken this nn, the whole dtrain data. See this, we have used this whole train data. We have taken d1 also, d2 also, d3 also, and d4 also. Just see how much time we have taken d1. See here, d1 is taken 3 times. So how much time d2 is taken? D2 is taken also 3 times. How much time d3 taken? Let's see, d3 taken also 3 times, and as well d4 also taken 3 times. So each chunk of the data sets we are considering 3 times for k-fold cross validations. So if you just summarize this thing here, if we just summarize this thing here, so we here we take h d h d I is e die is di means from dtrain from training dataset for VSTI. We have here we take HDI for dtrain for train on training the model k dash minus 1 time. Okay, k dash minus 1 time. If we just sample how much here, k dash is equals to 4, so we take x chunk x chunk to training our model from our training data sets 3 times, because k dash is equals to 4. I think this thing is clear. Okay, so what we have doing the job, just so we have give a query point, and on this query point, and we are built the using simple dtrain for an, using dtrain for ann, this for this query point, for this query point we are using dtrain for our query ann, and also we have taken this dtrain to build our 3 nearest neighbor model, to build our 3nn. Actually we have taken the whole dtrain. Let's simplify this thing as nearest neighbor, also as k. Okay, but let here k is equals to, but here k is equals to 3. I think this thing is clear. Here we have taken sample whole the dtrain datasets, as training, and also for cross validations to find the right key. Okay, now the same things for, and now for cross validations you will just see the same things, from the how to find the accuracy from the unseen data, the same things, all same job also doing here. So the same things to find the accuracy, the same things also doing here. So now to find the accuracy, the same jobs also doing here. Here we are simple using the test data set. Here the test data set is simple 20%, or another language. To build this model we have not, until we have not used this test data set, this is called the unseen data or k-fold cross validation details, because only we are using this 80% information of the whole data to build our this classification model. If this unseen data means state test data we are using here to find the accuracy. Suppose let's take accuracy of this 3ann model on our test data set is, let's see this accuracy, let's see 93%. Same thing is considered on unseen data. The same things also, this same number also considered in previous example. Here also I am taking this this accuracy on this k-fold cross validations also 93. So let's take, but just depends on our data sets. Actually if you implement this theory on a real data sets, then you can see is the actual value of the accuracy of unseen data, then you actually see. So now the main question is, sir, we have already learned how to choose a right key by simple cross validations or simple k dash fold cross validations. How to choose this right key? How to find the right key? This is okay till now, okay. But here you have introduced one terminology, k dash. Now, how to decide the right value of the k test? It will be, sir, I will divide, I will parties, I will just I will divide the whole training data set in 4 parts or 5 parts or 10 parts or 11 parts. So how many parts it will be better to take or to find our right k? So what will be the right value? Now the big questions is that now the big question now the big questions is that what is the right value of k test? What is the right actual value of the k test? What is the right value of this k test? Okay, so in general, typically the data science engineer or mathematicians or scientists are taken k test. The k test value is equals to 4 or 10 or k test is 100. Typi- typically the data science engineer, data scientist are taken k test is equals to 10. This is a big questions, and this is a big problem. In till now it is a research problem how to find a right k test for finding. But in general, rule of thumb for this k test is 10. So a 10-fold cross validation data. This is the simple rule of thumb. So mostly, typically, the data scientist, data engineer, mathematicians are used to find the right key. Or not only for KNN, it is these techniques are used in many. Just you will see these techniques also used in logistic regressions, and these techniques are also used in naive Bayes techniques. This also are used in simple for hyper parameter tuning. This cross validation technique and k test cross validation techniques are using, not only this k nearest neighbor algorithm. Now the big problem here also a big problem. So the big problem is here time. It's time to it's time it takes to compute the optimal k in kn and increased by k dashed times. We have seen the k dash time complexity to of our, so we have seen this thing, time complexity of knn is order of nd. We have seen this thing, time complexity. By example, if we use this k dashed cross validation technique, this time will increased k dashed time. It is increased k dashed time. K dash times of order of nd if we used k dashed fold cross validation. Okay, so the thing, if we write the time it takes to compute the optimal or the best, both the same thing, optimal k in knn increased by k dash times if we used k dash fold cross validation. Sample in typically we are using this k dash is equals to 10. This is the simple rule of thumb, not necessary for exact given, but typically this thing is used by data scientists. This is simple the rule of thumb. I think the this lecture the motto of this lecture is clear. What is actually k-fold cross validations, and simple here. Actually we have taken the k nearest neighbor, so instead of repeating the k for the both time, I am using here k dashed, but both the same things. If you don't be confused, if any books or author are using k-fold cross validations, and this is the same thing of k-dashed cross validations, k-dashed cross validations in our lectures, and the k cross validations both the same thing, because so instead of repeating k both the same k, so because of understanding purpose we have taken here k dashed. I think this thing is clear all of you. In cross validations we have the simple thing we have doing here. In cross validations we have actually doing the partitions our data sets in three parts. We have see this thing three parts, but instead of doing the three parts, because here we have using the neighbor point only 60% for of data, only we are using the 60% of data for our near point, so we have lose here the 40% informations. So to improve these things here, we are simple using the 80% of the data as our near points, and also we have taken the 80% our data to compute the k. By how we will do these jobs, so simple we are doing the partitions our whole the training data sets in the k dashed chunks, and by simple repeating this thing for each k, we have doing the same thing as cross validations. Just the call of the k fold cross validations means that we have just partition, we have just holding our training data sets as k dashed fold times, nothing else. Just we have holding this our training data set in k dashed fold k dashed types, and we have doing the same job. Okay, just considering the s chunk, but on our training on our training time, we have just considering this k chunk on our training time, we are doing the same job. Rest of the things are the same. I think the simple thing is clear all of you, and the main thing is the why actually we have taken this job, because of this thing, because of the lose of informations, because we have loss of most of the informations, means 40% of the informations here we have lost. But in k-fold cross validations we have seen only we have lost here 20% informations. Rest of the 80% informations we have totally used to build our model, and the rest of the 20% only used to actually to test our data. Hence this thing is actually used in as unseen data. I think the thing is clear. Although if you have problem, please I request you please revisit this lecture again. I think then it will be clear. Although if you have any problem, please comment below. I will try to explain the thing as simple as possible. I will try to give my best to understand you, understanding this learning technique as better as possible. Okay, so today's class is all about that, so we'll see you in next class.